morning, students. Today I am going to discuss a new topic, students. The topic name is here numerical solution of ordinary differential equation. Okay, students, numerical solution of ordinary differential equation. We already discussed, students, numerical solution of ordinary differential equation and how to find the solution of ordinary differential equation by applying numerical solution, students. Okay, what are the methods, students? Taylor series method, come on, Picard's method, and then Euler's method, and then RK method. Okay, students, Rangakutta method. Now in this class I am going to discuss Taylor series method, students. What, students? Taylor series method. Write down Taylor's series method. Taylor series method. Now I already told you, students, this is ordinary differential equation. We are finding solution, students, by applying numerical techniques. So the ordinary differential equation form ordinary differential equation of the form dy by dx, that is equal to f of x comma y, students. What, students? F of x comma y. He given y at x naught, that is equal to y naught, students. Y at x naught is equal to y naught. This is a condition, students. Now we are finding y at x, students. Y at x. Once again, students, the problem is of the form dy by dx, that is equal to f of xy, and he given, students, y at x naught is equal to y naught, and we are finding here y at x, students. Y at a specified point x, students. To find the solution of this differential equation, I am using here, students, Taylor series. So you write down, students, Taylor series method. Or, students, Taylor series method. The formula is here, students. Yn plus 1, that is equal to yn plus h by 1 factorial into yn dash plus h square by 2 factorial into yn double dash plus h cube by 3 factorial into yn triple dash plus h power 4 by 4 factorial into yn power 4 plus and so on. Here, see, students, n values, say n values here 0, 1, 2 and so on, students, and h value, students, h is equal to x minus x naught. H value, students, x minus x naught. Once again, students, yn plus 1, that is equal to yn plus h by 1 factorial into yn dash. Whenever we have h here, yn dash, students, h square, yn double dash, h cube, yn triple dash, h power 4, y power 4, students. In this way we can easily remember formula, students. Okay, right. See, students, I want to substitute n is equal 0 here. So n is equal to 0. We get here, students, y1, that is equal to right hand side, students, n value is 0. So y naught plus h by 1 factorial into y0 dash plus h square upon 2 factorial into y naught double dash plus h cube upon 3 factorial into y naught triple dash plus h power 4 by 4 factorial into y naught power 4 plus and so on. Now see, students, y naught. What is y naught, students? We know y naught here. This is y naught. Okay, students, and h is x minus x naught. Now see, students, y naught dash, y naught double dash, y naught triple dash, y naught power 4. Now if you observe differential equation dy by dx, students. What, students? Dy by dx. Dy by dx means, students, it is y dash. Okay, students, y dash is equal to f of xy. Y dash is equal to f of xy, students. Now y double dash students, y double dash. So you find y double dash and y triple dash and y power 4 students, y power 4. Thereby you substitute y naught, the point students, the point. For example, if I am taking here dy by dx, that is equal to say xy students, xy. Now this is y dash students, this is y dash, that is equal to xy. Y double dash means students, y double dash means apply u variable here. So x into y dash plus derivative of x is 1 into y students. Now see students, y naught dash. Y naught dash means students, y naught dash means here we have y naught dash. Here we have students x and y. So you write here x naught and y naught students. What is x naught students here? This value is x naught students. You substitute x naught value and y naught value students. You get y naught dash. Now here students, y naught double dash. Y naught double dash means students, here x naught y naught dash plus y naught students. We know x naught here. Y naught dash students, you already find here y naught dash. You substitute here. Plus y naught means this value. In this way, you are finding y naught dash value, y naught double dash value, y naught triple dash value and y naught power 4 value. Okay students, this is about the complete formula students, right, to find the y1 value. Now if n is equal to 1 students, come on tell me n is equal to 1 here. So y2 students, that is equal to this time y1 plus h by 1 factorial into y1 dash plus h square by 2 factorial into y1 double dash plus h cube by 3 factorial into y1 triple dash plus and so on. Similarly, if n is equal to 2 students, y3, that is equal to this time students y2 plus h by 1 factorial into y2 dash plus h square by 2 factorial into y2 double dash plus and so on. This is the Taylor series method students. The advantage of Taylor series method is, say students, f of xy, I am taking here xy students. We can simply differentiate the students. Okay students, and also it can easily applicable to computer programming students, computer programming. These are the advantage students. Now here we have disadvantage students. Whenever given in place of xy some fractions, okay, or higher order, in such cases, to find the differentiation, it is very tedious students, very tedious. That is the disadvantage students. Okay, finally the Taylor series method is, he given an ordinary differential equation, okay students, with a condition. We are finding a value y at x. To find the differential equation, we are using this formula students. Yn plus 1 is equal yn plus h by 1 factor into yn dash plus h square by 2 factor into yn double dash plus and so on. Okay students, this is about Taylor series method. If you have any doubt, please comment in the comment box students. Hope you understand. Thank you for watching this video. Jai Hind.